Guys, welcome to lab session 3 for COMP389 589. Today we're going to be covering off on the final topics on our tour of SQL within the Postgres database management system. The content from today's prac is drawn from both chapters 4 and 5, so we're basically just tidying up our coverage of those two chapters. We'll be looking at the string comparison operations and arithmetic operations back from chapter 4, and then we'll be finishing off our look at chapter 5 with the grouping and aggregate functions and the creation of views and virtual tables. And you'll need to understand all of these ones for the first practical assignment coming up. So before we get started, as usual, we'll be looking through examples on our company database. So if you can go through, create a new prac for week 3 rather, and go through and actually do a dump of your prac1 database into that new database there. So if you just use a /i command to run the backup that you created back in week 1 into that database, we can create that and have all of our tables there. And I've done that already over here, so you can see that I've got all of my tables listed there, and we've got some data in them as well. So we'll check that one. You can see we've got some data in there as well in our department table. So go through and do that so that you can run through the examples that we're going to be looking at today. So moving forward, the first thing we're going to be looking at are the string comparison operations. So far through our practical exercises, we've only really compared a string type attributes for equality. So we've only said if one equals another, we want to match a particular condition. But SQL and Postgres actually provide facilities for complex pattern matching. And that's achieved through the use of the like operator. So pattern matching facilities basically make use of these special characters to indicate the pattern within the string that we want to match. So, for example, if we are allowing 0 or more characters in a particular string, we can specify that. For a particular part of our string, we can specify that using the percentage symbol. If we want to specify an individual character that has to exist, then we can use the underscore. So the best way to learn these is actually through examples. So the first example we've got here is to retrieve all of the employees with an address in Houston, Texas. So you can see we've actually set up a select statement here. We're selecting from the employee table, and in the where clause we're using the like operation. And we can see here we're just checking where the address is like, and our pattern, which was surrounded by our single quotes because it is still a string, we've placed the percentage symbols in there to indicate that we're allowing any number of characters either side this particular string. So any string, any value in the address field that has the Houston comma space TX string in there, Texas string in there, will actually be returned within that. So if we copy that one and drop that into our window over here, you can see that we actually get 5 records returned there, and these individuals all have addresses with the Houston, Texas string in them. To specify individual characters, we do that using the underscore. So in this example here, we're actually looking for employees that were born in the 1950s. So we want the third character to actually match on the 5 in 1950. So it's stored year, day, month, etc. there. So we've got so it's stored in that particular format. So it's going to match the particular. The third character there is going to be a 5 in that particular situation. So we're specifying that it has to be specific characters in specific positions there. If you actually wish to use the percentage and underscore characters as part of the strings, part of the string literal for matching, you have to escape them using the slash character there. So you can just escape them. So in the examples below here, we've actually escaped the percentage character there using our slash. So there's some more interesting examples in the Postgres documentation online. So if we jump in here quickly, we can see that that there's actually a full manual page for using the like and similar to operators and all of the regular expressions. So make sure you have a quick review of that just so you know what's there for you to use. We've got some other examples here taken from the man pages. So if we jump in here, you can see here that we're actually we can use these in a select statement rather. We don't want to use them individually. So if we wanted to actually try some of these out. So in the first one we're looking for ABC, we're comparing it to ABC. Obviously that's going to be true. In the second one, we're comparing the string ABC to a percentage. So the A has to be our first character, then we're allowing any number of characters after that through the percentage symbol there. That's what that signifies. So we've got our BC after that, so that's going to evaluate to true. Here we're using our underscore characters to specify that there has to be a character either side of the B. So again, that will be true because we'll have the A and the C, which will match to our pattern here. And we've got B in the center. And our final example here is false because we're just comparing our string ABC to the string single character C. So if we go through and run these, for example, if I grab the third one down here, I can drop that one in and execute it, and you can see there we get one row of data return indicating that it's actually true. In addition to these basic matching operations, Postgres provides POSIX regular expressions through the use of the similar to statement, and these add additional pattern matching characters or pattern matching symbols to our repertoire there, so that we can make some even more complex strings. So here we have, we can use the pipe character to specify that a character must match alternatives from a list. We can specify repetition using the asterisk character. We can denote repetition from one or more times using the plus character. The question mark character indicates a repetition of the previous item 0 or 1 time. And we can actually specify n times repetition, and we can group items into logical expressions there. So we've got a couple of examples here below, again using our same format. Here similar to will return true because we're matching ABC, we're comparing ABC to ABC. Here we'll return false because we're comparing ABC to the string A. Here we're combining our operators together, so we've got the string ABC and we're comparing it to the pattern where we're allowing any number of characters either side of a B or a D. So that one's going to return true because in our ABC expression, B will match to this particular expression here. So you can see that we've actually grouped these together using our parentheses here, so that we know that the pattern is atomic. Here we're going to return a false because we haven't actually put a character and specified that there can be a character before our pattern. So in this situation, the A won't match the pattern that we've defined there, so it'll actually return false because it expects either B or C to be first, and A is first in our string. So go through and have a play around with those examples. String type attributes can be concatenated together using the concatenation operator, which is the double pipes. So for example, if we want to grab the first name and last name in a single field and name it full name, we can concatenate them together, and you can see here I've actually put a space between them so they'll appear nice and readable. So if I go and run that up here in my terminal, you can see here that I get one column of data return and it's called full name, and we can see that the names have been concatenated together in that pattern. So just a really quick and handy tool there if you ever have to return a full name or a particular set of strings all concatenated together into one field. So that's a brief look at pattern matching there. There'll be some examples, some questions to work through at the end, so we'll go through and have a look at those in the exercises. The next section we're going to look at are the arithmetic operations and aggregate functions. So the standard arithmetic operators, such as our plus, minus, times, and divide, can be applied to numerical values and attributes with numeric domains. So we can just do that within the attribute list that's actually returned within our select query. So we can see here, if we wanted to give everyone a 10% raise in their salary, we could actually see what that looks like by actually multiplying our result here that's returned from the employee salary field by 1.1, and that will actually just return the result that we want there. So if we go through and we run that one, just for any quick example, you can see here that we've increased the salaries. If we go through just for a comparison there and actually remove the 1.1, you'll see that it's been increased by 10% there. So I'll just go back and drop that one off. We can see there that we've actually dropped that character, that amount off, and we've actually just multiplied. We've left them unmultiplied in there, 10% less. So that can be applied in any way throughout your queries. Just a little quick note there. Moving on to the more important section here, we're looking at the aggregate functions. So the aggregate functions are designed to summarize information from multiple tuples into a single tuple summary. So the functions that we have there have at our disposal include, but they're not limited to, count, sum, min, max, and average. So if we want to apply these operations to a group of records, when then they'll return the count and the sum and the max and mins from those particular records. They're actually applied to individual attributes specified within a select clause. So we can see here below, if we want to find the sum of all salaries and the maximum of all salaries and the minimum of all salaries, working from the employee table, we'd actually use a query like this. We'd have a select query, and in the return, in the attribute list, we actually apply these aggregate functions. And when we run that, we'll get a single row of data returned into our database here. And we can see we've got the sum and the min and max of all of our salaries. We can add a where clause to those to restrict the records that the aggregate functions are actually applied to. So in the first example here, we're actually finding the sum of all salaries along with the max of all salaries, the min of all salaries, but we're only limiting it to the department research. So we've done a join here. We're using an inner join with the department between department and employee on the department number. So if we go and drop that example in, we can see here that we'll only get a few rows of data only get a single row of data returned rather, but it's much less. So the numbers are different from our overall data set there, indicating that we've actually restricted it to our department name. The other function that we can look at here is the count function. So we can actually count the number of tuples returned by a query in our where clause. If we do that, we can see here that we return the number of employees in the employees table. We can combine this with other operations. So here we're combining it with the distinct operation to actually count the distinct salary values. So if we drop that one in, you'll see that there's only 32 distinct salaries. So we can see that we're removing the actual tuples that are duplicates. If we remove our distinct operator there, you can see that there's actually 40 rows of data counted, which is one for each employee. Now with our aggregate function, usually we'll actually use them with a group by statement. So in many situations, we will need to apply aggregate functions to subgroups of tuples within a relation, and we'll want those all grouped up, and we'll have a summary row for each of our groups returned in our query. So the group by operation allows us to partition a relation into a set of non-overlapping subgroups, and basically we specify an attribute that we want to use to create those subgroups. So tuples with the same value for that particular attribute will be grouped together. So to understand that, we've got an example down here. Here we're retrieving the number of employees and the average salary for each department. So we're doing that for each employee, so we're working from the employee table. And you can see underneath our from clause here, we've actually put in the group by operation. And we're going to group all of our employees by department number. So that means that we will have a row of data returned for every distinct department number that exists. So when we run that, you'll find that we only have a few rows of data actually returned. So you can see there are 7 different rows of data returned. Now if we do a select from our department, you'll see that there's actually 6 departments. So we've got a row of data, we've grabbed the count and average salary of employees from each of those departments there, because we've grouped by all of our departments. So it's kind of similar to a roll-up operation that you can do on a spreadsheet. We can combine our group by statement with a where clause to actually restrict the tuples that are actually returned or listed within our within our aggregate operation. So here we have an example where for each project that has 2 or more employees, list the project number, name, and number of employees working on the project. So you can see here that we're actually performing a count, and we're grouping by the project number, and the project name. Now we only want projects returned that have got 2 or more employees working on it there. So if we go through here, we're also joining the project table to the works on table to achieve that, and we're doing that through by linking the P number field to the P&O field. So if we grab that example and drop that in, you can see that we'll only have projects returned that have more than 2 employees working on them there. So if we go back and actually take that bottom clause off, you can see that we actually get more rows of data returned there. We get 11 versus 9 returned there. So that shows us how to actually roll up data and apply our aggregate functions to subgroups there, and there'll be some questions about that in the exercise following. The final little section we're going to look at here is creating views or virtual tables. So a view is basically a virtual table that's derived from 1 or more base relations or base tables within the database. They're used to provide an additional layer of abstraction between the implementation of the database and the applications that are drawing on it. So the idea is that you could make changes to the underlying table, and the only change that you need to make as far as the application is concerned is a change to the view, because if we change the view to use the new data structure underneath, we don't need to make any changes to the user level applications drawing on that. So the view can simply be updated to return the expected format, the format expected by the application. And this is achieved, we create views using the create view statement, and it's got an as clause as well. So if we go down to examples here, the first one is we're going to create a view that directly inherits the names of selected attributes from the base table. So here we've got our works on view, so we're just working on the works on one table. We're linking that to the project and employee tables, and we're selecting the first name, last name, and P name and hours. So we're not actually doing any restrictions here, we're just combining some tables together to create a convenient view of our data. So we've created our view, and we've got our create view prompt return there, and we can go and actually view the data in that table through a standard select statement. So we treat a virtual table exactly as we would a normal table in our queries. You can see there that we've combined all of that data has been joined together for us, and we're only returning the columns of data that we've specified there. So we've created another view for the database that's based upon these base tables lying underneath here. We can also rename the attributes as part of the view declaration. So here we're creating our view department info, and we're going to have these 3 columns, and they're going to map to these 3 columns here. So our count and our sum of the salaries there. And that's coming from department employee that are linked by the department number, and we're grouping them by department name. So for each department, we're going to get a count and the sum of the salaries actually put in there. So we'll go through and create our view. You can see that the view has been successfully created, and now we're actually going to go and select our view, select the data from our view. Now we can view our data, and you can see we've got a row returned for each department. So there are 6 departments showing the number of employees and the total salary there. So we can access that at any time. If we want to remove a view, actually if we want to view what views we've got in our database, we can use the /dv command. So that shows that we've got our 2 views that we've created there. Now if we want to drop our views, we just use the drop view command, and those views will actually be removed from our database there. So you can see we just dropped the department info view. Data that's presented within the views is always up to date. If we modify the tables on which the view is based, then the queries on the views will return the updated data. Views data returned, but the data returned by a view can either be retrieved directly from the base tables, or it can be pre-calculated and stored. When it's pre-calculated and stored, it's referred to as a materialized view. Now, all of that's managed by the database management system, so you just only have to know how to use them and actually create them within your database. You can perform update operations on views. However, the views must directly map to the base relations. Otherwise, you can have multiple combinations in which the data can be updated, and the database management system can't resolve that. So, for example, in our second example here, there's no way that the database is going to be able to make updates to the base tables through updates to that view, so it simply won't allow it. But in the first example, it's a little bit simpler, and it should be able to map those variables back to those particular tables. You should avoid it because it's usually not a good idea, as the updates can actually be unpredictable. Sometimes it'll default to one of multiple values, and it can actually make your database quite messy. So you shouldn't be updating views, you should only ever be updating the base tables. So that covers off on today's material. So to finalise our look at our databases, we've actually got some queries here. So you've got eight questions to run through and do. The first four are actually just running through and doing some queries using some string matching and some mathematical aggregate operations. The second set of questions involve creating views and again combining our use of mathematical operations and aggregate operations in there as well. So start moving through those. If you have any questions, email them in, and these will be very relevant to your assignment as well, because they're very similar to the type of style of questions that you'll be getting in your assignments in the exams. So go through and cover off on those, and if you have any questions, email in. So that's all I've got for today, guys, and thanks.